So today we're going to start our part 2 for the fire alarm system. If you haven't gone through my first part, please go through my first part before you start the second part so you can understand the complete concept of about the fire alarm system. So it would be very easy for you to understand the full concept of about the fire alarm systems, how they will work, what kind of what are the different types of smoke detectors, heat detectors, and other control panel units are there, fire control panel units are there, and how they will work. Okay, so let's start our part 2, notification appliances. So in this part we will discuss about the notification appliances and how they will work and what are the criteria as per NFPA requirements. So all these things we will discuss in this training. Uh, Before that, I would like to request you, please subscribe my channel and like my videos, and please do share with your friends and colleagues as well. And thank you so much for your support and your love. So let's start our training, notification appliances. So operating modes, in this one you can see that table A, there is a duration 8 hours, 6 hours, 4, 3, 2, 1.5, and there is a dB 90, 92, 95, 97, 100, 102, and 105 till 120. This is the source from the OSHA 29 CFR 1910.5. So these are the requirements of the dB noise level. Now the operating modes, there are two operating modes for alarm notification appliances: public operating mode and private operating mode. Fire alarm audibility design goals, occupancy descriptions, public mode. Audible or visible signaling is provided as evacuation notification to occupants or inhabitants of the area protected by the fire alarm system. Example: business, educational, residential, sleeping areas, industrial, and storage occupancies. So in there is a public mode that these alarm systems has been provided. Now what should be the minimum sound level for these areas, public mode? So at least 15 dB above the average ambient or normal sound level, or 5 dB above the maximum sound level that lasts at least 1 minute. So the minimum sound level is 15 dB, and that should be above the minimum 5 dB from the maximum sound level of that area. So let's say that if any area maximum sound level is 20 dB sound is there already, so you have to provide the alarm signal at least at 25 dB for minimum 1 minutes. So that is the requirement. Private mode, trained individuals are present 24 hours a day to take additional action when there is an emergency. When it is a private building, there is a trained fire wardens, first aiders, and fire emergency team is there. They are ready to take the actions. Examples: hospital patients care areas, operating rooms, or critical care areas. In situations like these, sound levels must adequately notify the occupants to evacuate, but not too loud as to startle them. So note, emergency signaling may not be required to meet ADA requirements or UL 1638. Now in the private mode, at least 10 dB above the average ambient or the normal sound level, or 5 dB above the maximum sound level that lasts at least 1 minute. So it should be at least 10 dB above the average ambient sound. If the average ambient sound is 5 dB, then you have to give more than that 5. It should be minimum 10 more. 10 plus 5, it should be 15. And if the maximum sound level is 15, you have to add 5 more dB, so that should be 20 dB. What is average ambient sound level? It is over time that any person is present or a 24-hour period, whichever time period is the lesser. So that is the average ambient sound level. What is maximum sound level? Is it peak sound level? No, it is not the peak sound level. In acoustics, it is the maximum RMS value that lasts at least 60 seconds. So the maximum sound level that should last for 1 minute. Now annunciator panels. We'll look into the annunciator panels. These are the annunciator panels. When the firefighter arrives on the fire scene, The first arriving units typically respond to the main entrance or address site to the building to investigate and initiate operational activities. Upon entry into the building, firefighters are likely to immediately look for a piece of fire alarm system equipment known as the annunciator panel. So this is the annunciator panel. The annunciator panel is a type of notification or indicating device that provides valuable information concerning the initiating device, system involved, the area of the building where the fire is located. We can say this is the fire alarm control panel unit also. So where there you can get the information. Power expander panels. When building renovations leads to fire alarm system changes, fire system designers often discover existing fire alarm control panels do not have the power capacity to support all of the additional required audible and visual notification devices. Modern day notification appliances use considerable electrical current to operate. So it is always practical or cost effective to place all the power and circuits in the fire alarm control panels. Now, we'll look into the fire alarm systems classification. Fire alarm systems. Fire alarm, supervising station alarm systems. Under the fire alarm system, there is a fire alarm, protected premises alarm and signaling systems. After that, single and multiple station combinations and the household signaling systems under the fire alarm. Then we have the supervising station alarm systems, central station service alarm systems. Then we have the remote supervising station alarm systems. Then we have the proprietary supervising station alarm systems. Now we have the public emergency alarm reporting system, that is alarm boxes, publicly accessible alarm boxes, auxiliary alarm boxes, local energy type, and hunt type. These are the fire alarm systems. So single and multiple station combination and household signaling system. So this is the single and multiple station, the household systems that is used for the fire alarm system. This is the central station service alarm system, centralized fire alarm system. Now, communication with the central monitoring systems. How we can communicate in fire alarm central monitoring systems. So we'll start from the one. Just a minute. So this is the complete design and complete system, how the fire alarm central monitoring system, how they will work, how they will receive the signals, and how they will activate in a fire alarm system. So these are the different types that we have. So as you can see, IP communication, there is the IP communication, digital alarm communicator transmitter, digital alarm transmitter located fire alarm system site, and after that communication pathways and digital alarm communication. Then secondary is here, the off hook back to on hook time cannot exceed 90 seconds per attempt and must be PSTN and primary. So these are the complete diagram of the central monitoring systems. So once the premise is on, what will happen? And if there is any fire, then it will go to the signal and that will receive here. And after that, off hook, DSCT seizes a phone line, then it will go here, then it will go here, dials, then release phone line. Now, remote supervising station alarm systems. This is the remote receiving system, protected premises number 1, protected premises number 2, protected premises number 3. What will happen? Remote receiving control unit annunciator. So they will receive the signals. Telephone will telephone exchange, input outputs, and lease telephone lines. Fire station. Proprietary supervising station alarm systems. This is the proprietary supervising station alarm systems. Public emergency alarm reporting system. So the public they can report any emergency. Emergency communication system. Emergency communication systems, one-way emergency communication systems and the two-way communication system. In the one-way, in building fire emergency voice alarm communication systems, in building mass notification systems, wide area mass notification system, and distributed recipient mass notification system. In the two-way communication system, in building wired emergency services communication systems, radio communication systems, and we have the area refuse emergency communication system, stairway communication system, elevator landing communication systems, and occupant evacuation elevator lobby communication systems. So this is the one-way emergency communication system, and these are the two-way communication system. Communication systems. So there is the images of emergency communication system. Same here. So by these we can communicate for the emergency. Interface with other systems. Unlock exit door, close doors, recall and shut down elevators, turn on or shut down AHU, start up smoke control and management equipments, close fire dampers, monitor and activate fire suppression systems. So these are the other systems that will interface with the alarm system. Interface with other systems. This is locked. If it is up, it is locked. It is unlocked. Okay. So these are the interface with the other systems. Fire alarm system, it is interface with the other systems. So there is the door lock. Now elevator nomenclature. So elevator hoistway. This is the elevator hoistway. Opening through a building or a structure for the travel of elevators extending from the pit floor to the roof or floor above. So whenever there is any fire, so all the elevators, they will shut down. They will not operate during the emergency. And we normally see that there is a sign on the elevator that in case of fire, do not use the elevator. Then how these elevators, shaft, the pit, how they are working during any emergency, during the fire, that we will look here. So this is the photo of elevator hoist way. So what will happen? Elevator will travel through this way, up and down. And this is the elevator pit. The portion of the hoist way extending from the sea level of the lowest landing to the floor at the bottom of the hoist way. So this is the bottom level of the lift. We are calling it elevator pit. And we have the shunt trip, shutdown of the electric power to the elevator resulting from the heat detector activation in the hoistway or elevator machine room prior to a sprinkler operation. So this is the shunt trip. So what will happen whenever it will receive any smoke or any heat from the heat detector, then what will happen? It will shut down the elevator. After then, firefighter services function that allows firefighters to take control of elevators through the key access to use them as needed to firefighting and rescue operation. So firefighter services, firefighter, they will use the elevator display to use during the firefighting or the emergency. Elevator construction, how the elevator should be constructed. Elevator should be constructed according to the International Building Code, IBC, NFPA 101, the Life Safety Code, ASME 17.1 Safety Code for elevators and escalators. Elevator hoistway or shaft, as they are sometimes called, are required to be constructed of materials that provide a 2-hour fire resistance rating. So whatever things you are using in the elevator or the hoistway or the shaft, they should provide the 2-hour fire resistance during the fire. Now the elevator constructions hoistway, 3 stories or higher are required to have the smoke venting of the hoistway for the removal of smoke and hot gases during a fire conditions. Installation of SD shell as per the below clause, NFPA 17 2013 clause number 21.3.6. When sprinklers are installed in the hoistway, heat detectors have to be installed to activate prior to the sprinklers heads and activate the shunt trip function of the elevator controls. So before you install any heat detectors, fire sprinkler, before that there should be the heat detectors. When the heat detectors will receive any heat, any temperature will increase, what they will do, they will activate the shunt trip and function the elevator controls. And what will happen? These fire sprinkler system that will be activated. Now, elevator construction pit. How the elevator pit should be constructed. A sprinkler coverage is required in elevator pits for hydraulic elevator that use flammable hydraulic fluid. If there is any flammable hydraulic fluid, that should be the in the hydraulic elevator. There should be a sprinkler coverage should be there. So smoke detectors in pits shall not be used for recall purpose unless listed for environment. So these are the smoke detectors. If it is not hydraulic or non-flammable fluid is used, then no sprinkler heads and no detection device are required in the pit. If there is non-flammable liquids or the fluids are used, then there is no required for the sprinkler heads or the no detection devices are required. Elevator construction machine room. Machine rooms must be constructed to the same or the greater rating as the elevator hoist weight. They should be 2-hour fire rated resistance rating or more than that. Plumbing systems other than sprinkler piping cannot be located in the elevator machine rooms because of all of the electrical equipment located there. So ASME A1 17.1 requires that an ABC rated portable fire extinguishers be located in all elevator machine rooms. So there should be ABC rated fire extinguisher should be there. NFPA 101 2015 clause number 9.4.5, the life safety code requires elevator machine rooms with a travel distance exceeding 50 feet, which is 15 meter, 50 feet, which is 15 meter above the level of exit distance discharge, or 30 feet, 9.1 meter below the level of exit discharge, be provided with independent ventilation or air conditioning systems to maintain temperatures during firefighter emergency operations. Now, elevator machine rooms are usually sprinkled because of the electrical equipment in the room. Having water discharge from the sprinkler system can be damaging to the equipment. So, water discharge should not be there to avoid any damage to the electrical equipment. When installing a sprinkler in the machine room, it is a good idea to have a shut-off valve in the sprinkler piping just outside the machine room, so that the water cannot be shut off as soon as the fire is extinguished. Elevator recall for firefighter services. Why? Building occupants should not use elevators during a fire or when the fire alarm is sounded. Why we should not use that one? Elevators can be programmed to be recalled automatically to a designed floor or alternate floor. So what can happen? That elevator, as soon as the fire alarm will sound, that will suddenly come out down the pit, the ground floor, on the basement or the top floor, it can go. So that's why elevator should not be used at that time, and the people they can stuck. When the fire alarm system in the building is activated, which will keep building occupants from using elevators during a fire. Elevators are generally not safe for civilians to use under the conditions. Firefighters, however, may be able to use. Firefighters may be able to use, but civilians, normal people, they should not use. Elevators to transport personnel and equipment if it is determined that it can be done safely. So elevators to transport personnel and equipment if it is determined that can be done safely, that can be done. Now, elevator recall for firefighter services. Sorry, sorry. Initiation. Fire alarm initiating devices, smoke or heat detectors are installed at each elevator floors. So each elevator floor, there should be the heat detectors or smoke detectors, heat detectors, and sprinklers. Floor switches in or associated with elevator hoistway and elevator machine rooms will also activate elevator recall. It is required as per NFPA 72 2013, clause number 21.3.14.1 and clause number 21 3.1.14.2, and should be within 20 feet, clause number 21.3.5. It should not be more than 21 feet. A single detector can cover 3 elevators placed within the shaded area. A single detector is here, and it can cover 3 elevators under the shaded area. You can see here it is elevator 1, elevator 2, elevator 3, and it is covering all 3. Elevator fire service function. Phase 1 firefighter service, phase 2 firefighter service. So elevator fire service function, phase 1 firefighter service. A 3-position key, the switch off of fire FA devices are allowed to initiate elevator recall phase 1 operation. So in the bypass position, if you will take the key on the bypass position, what will happen? Normal elevator operations are restored regardless of the status of elevator lobby detectors. So it will, elevator operations are restored. In the on position, if you will take the key on the on position, what will happen? All elevator cars controlled by the switch, usually only those in the elevator bank, will return to the designated level non-stop, and doors will open and remain open. So if it is designed that elevator should go down basement or go on top, so once you will put on the on key, then it will go straight away on that floor and door will remain open. In that position, elevators will operate normally and be controlled by the smoke or heat detectors in the lobbies. If you will take the keys on the off position, elevators will operate normally and be controlled by the smoke or heat detectors. Elevator fire service function. So this pattern you may have seen inside the elevator. Phase 2 firefighter service permits fighters to manually take control of the elevators with an override key. Elevators with phase 2 operation also have phase 1 elevator recall as well. Phase 2 overrides all automatic controls, including the phase 1 recall. Phase 2 key switches are required to rotate clockwise from off to hold to on. So you have to rotate clockwise. Now, elevator fire service function phase 2 operational instructions. Item to operate car, insert key and turn on, press desired floor button. To cancel floor selection, press call cancel button. Then we have to open power operated door. So when flashing exit elevator flashing like this, so these are the instructions should be followed. Design and installation of fire alarm system. So we have to understand in this topic how we have to design and how we have to install the fire alarm system. The person who is designing and installing the fire alarm system, their qualification requirement. Personnel who are registered, licensed, or certified by a state or local authority, they are the only one who can design or install the fire alarm system, none other. Personnel who are certified by a nationally recognized certification organization acceptable to the authority having jurisdiction. Personnel who are factory trained and certified for fire alarm system design and or emergency communication system design of the specific type and brand of system, and who are acceptable to the authority having jurisdiction. So only these persons can design the fire alarm systems and they can install the fire alarm systems. Only these persons. Now, occupancy-based fire-based requirement. Internationally Building Code 2018 edition occupancy-based requirements. These are the requirements of occupancy-based. Occupancy, assembly, business, and certain other areas. Manual fire alarms. Yes, there should be. Automatic fire detection or smoke alarms. For the assembly area, not required. For the business, not required. Educational, not required. Hazardous area, yes, required. Institutional, yes. And residential, yes. Automatic fire detection or smoke alarms, that is required. Occupancy-based requirements, NFPA 1, NFPA 101, and NFPA 5000 2018 edition occupancy-based requirements. So NFPA 1, as per NFPA 1, NFPA 101, and NFPA 5000. Now the assembly, manual alarm required, automatic alarm not required, manual alarm required as per NFPA 01 and NFPA 5000. Yes, it is required. Automatic fire alarm required and automatic fire alarm required. So there are certain requirements as per NFPA 1, 101 and as per 5000. So all these requirements is listed here that you can go through. Now, NFPA 101 and NFPA 5000 edition occupancy based requirements. So, there is the residential board and care. These are the different areas and same requirements as per NFPA 1, NFPA 101, and NFPA 5000 that you can go through as well. Now, installation and design. In order for a fire alarm system to work, there has to be some method tying together the initiating devices, notification appliances, fire alarm control panel, and other internal and external components and systems. Approved methods include fiber optic cable and bidirectional wireless communications, but most system installation still use wire as the primary connection method. Rule of National Electrical Code. The Fire Protective Signaling Systems portion of the code, National Electrical Code Article 760 details the specific requirements for wiring. Whichever wire you will use during these fire alarm systems, there are certain requirements and equipment installation for fire protection signaling systems. Specification include installation methods, connection types, circuit identification, and wire types, including gauges and insulation. The National Electrical Code places restrictions on the number and types of circuit combinations that can be installed in the same enclosures. Scope of NEC 760. The articles covers the installation of wiring and equipment of fire alarm systems, including all circuits controlled and powered by the fire alarm systems. If you need more information regarding the National Electrical Code, you can go through the National Electrical Code 760 that will provide you more detailed information regarding the wiring and other requirements. Power limited and non-power limited circuits. Power limited fire alarm control panel circuits. A power limited fire alarm control panel circuit is one that is inherently unable to exceed maximum voltage or is equipped with a power limiting source, transformer, or battery. And the circuit breaker. Generally, these operate in the 24-volt direct current range, although they may employ higher voltage. So, fire alarm circuit. This is the power limited fire alarm circuit. After that, we have the power limited and non-power limited circuit. Non-power limited fire alarm circuits cannot operate at more than 600 volts. So this one can operate volt direct current 24 volt, but it cannot be operate more than 600 volts, and there is no other power or current limitations for these systems. Usually these are used in 120 volt alternating current system, which have been rendered generally obsolete by the advent of low voltage direct current systems. Types of cable. How many types of cable are there that we can use in our fire alarm system? Power limited fire alarm cable. Power limited non-plenum rated fire alarm cables is generally general purpose cable that is not rated for plenum use spaces. Power limited fire alarm risers cable. Power limited riser rated fire alarm cable is installed where vertical cable runs are required. This cable must have low flammability but smoke generation characteristic can be higher than those for a plenum rated cable. So it should have the more smoke. Power limited fire alarm plenum cable. Power limited plenum rated fire alarm cable can be installed in the plenum or other similar spaces. This cable must meet strict flammability requirements and must have low smoke generation characteristics. Non-power limited fire alarm circuit cable. Non-power limited fire alarm cable is for generally use but not for plenum. Rising ducts or spaces where there is environmental air can be used. Non-power limited fire alarm plenum circuit cable. Non-power limited fire alarm plenum cable can be installed in plenums, ducts, and other similar spaces that must be fire resistant and must have low smoke generation characteristics. Now the circuits and wiring. As per NFPA 72 regulations, discuss circuits classification and the types of circuit installed as related to the systems and devices. Three different types of circuits are used with conventional and addressable technology-based system. So initiating devices circuits, after then single line circuit, notification appliance circuits. So these are the three different types of circuits. Circuits and wiring. Initiating device circuits are installed with conventional technology system. Single line circuits are installed with addressable technology systems, and notification appliance circuits are installed with both. Power supply. Two independent and reliable sources of power are required to supply a fire alarm system. Then typically the main or primary source of power is supplied by a power utility. Primary power could be supplied by an engine-driven generator or equivalent that is under the constant attention of a trained operator. Once the primary power enters the facility, it must be protected from physical damage, that you have to make sure, and it must be on a dedicated circuit supplying the fire alarm control panel. And access to the circuit must be controlled and the circuit must be identified easily. Power supply, secondary power source, rechargeable storage batteries, and engine driven generator. So if the normal power source is not working, there should be the rechargeable battery storage batteries and engine driven generator should be there. If the storage batteries are used, they must have the capability to sustain power for 24 hours in normal ready mode and 5 minutes in full alarm mode at the end of the 24-hour loss of power period. So that is a requirement whenever you are using any secondary power source, if you are using any batteries. These requirements differ for emergency voice alarm communications systems and mass notification systems, for which 15 minutes of power in full alarm mode is required at the end of the 24 hours loss of power period. The second option, you have engine driven generator. When a generator is used to provide power as a secondary source, the generator must have 4 hours of battery capacity. No matter the secondary source, power transfer must be automatic and seamless, not allow for loss of system function, delay or interrupt signals, and take place within 10 seconds. So within 10 seconds, it should be started. Now, types of fire alarm signals. How many types of fire alarm signals are there? Types of fire alarm systems may provide three types of signals: alarm, supervisory, and trouble. Detect the presence of fire, notify the fire department, then notify to occupants and operator other fire safety system. Alarm signal. When an alarm signal sounds in a building, it is alerting occupants there is a fire emergency. So it is an alert signal. The alarm signal should support the occupants to immediately leave the building, call the fire department, or take other appropriate action to ensure life safety. Alarm signal must sound within 10 seconds. It is a requirement of a manual or automatic initiation device activation, such as a manual fire alarm box, a fire detector, or a water flow or pressure switch. Depending on the fire alarm system, this signal either will automatically be transmitted offsite so the appropriate action can be undertaken by the receiving party, or might require that a person make contact with the fire department to respond. After that, we have the supervisory signals. The supervisory signal sounds when there is a change in the normal ready status of other fire protection systems or devices that are connected or to the integrated with the fire alarm control panel. The typical supervisory signal sounds a constant tone, beep, or buzz, usually accompanied by a visible indication lamp, LED, or text information on the fire alarm control panel, and if installed, the annunciator. In many buildings, the fire alarm control panel electrically monitors sprinkler system control valves, dry pipe sprinkler system, air pressure, fire pumps status, and air temperatures of a sprinkler system wall room. Water temperature, level, and pressure in a water storage tank, and in some configuration, duct smoke detectors operation. So this is the work of fire alarm control panel, which is monitor all these things. For example, supervisor signals a change in the normal status of a sprinkler system control valve could indicate someone closed a valve, thus cutting off the water supply to the sprinkler system. The act may have been accidental, malicious, or necessary for service or maintenance activities. It could be anything. By electronically supervising the wall, those responsible can initiate an immediate response and investigation to determine the nature of the incident. How can we have trouble signals? It sounds when there is a problem with the system's integrity, such as a power or component system failure, device removal, communication fault or failure, ground fault, or break in the system wiring. It is common for the trouble signal to use the same audible signal and visible indicator as the supervisor signal to notify there is a condition requiring attention. System problems that generate a trouble signal should be investigated and resolved as soon as practical by building maintenance or engineering personnel because trouble conditions may prevent initiation or reception of alarm signals. So many times what will happen, a trouble signal is acknowledged and forgotten. The people they will acknowledge but they will forget. But newer fire alarm system must sound the trouble signal every 24 hours until the problem is resolved. That is the advantage with the newer fire alarm system. Types of fire alarm signals. So signal type, we have alarm, supervisory, and trouble. And possible condition. What are the possible condition? Could be for the alarm and supervisory and the trouble. So these are here. And what are the actions you have to take? Indicates an emergency that requires immediate action, such as a signal characteristic of a fire. So these are the actions need to take. Now, need of fault isolation in fire alarm systems. Fire destroys insulation on wires and short circuit destroys delivery of power or data. So what will happen? It will short circuit. The insulation on the wire that will destroy. SLC zone, a single fault on a pathway connected to the addressable devices shall not cause the loss of the device in more than one zone. Each floor of the building shall be considered a separate zone. If a floor of the building is subdivided into multiple zones by fire or smoke barriers and the fire plan for the protected premises allows relocation of occupants from the zone of origin to another zone of the same floor. Each zone on the floor shall be considered a separate zone. A single zone could be designated in the following ways: by floors where an SLC could not span multiple floors, by floor area where a large floor would be split into multiple zones based on a maximum floor area size. These are the other certain requirements. Now, need of fault isolation in fire. How you can avoid the fault in fire. There is a zone 1 and zone 2 alarm. And we have the zone 3. So these are the detectors, short circuit is here, and there is the fire, and there is the isolator. Now, the concept of reliability prediction of techniques for fire alarm systems. So this topic we will discuss in our third part. So we have finished our second part. So see you in the third part. Thank you so much for your time and patience.